Our objective for today, I can simplify exponential expressions using the multiplication properties of exponents. Read together, 1, 2, 3. I can simplify exponential expressions using the multiplication properties of exponents. So what is our concept for today? Tell your neighbor what to write in the Ferrier model. What's our concept for today? Very good, exponential expression. So you already wrote your objective at the bottom. And in the center, you wrote what? Garrett, what did we write in the Ferrier model?
Exponential expression.
Right, you wrote it already, right? Okay, good. So since yesterday we started with definitions, example, non-example, hashtags, without looking at your notes, fill in your Ferrier model for exponential expressions. If you don't remember the definition yet, give me at least 2 examples of what exponential expressions look like, what 2 of them that are not, and some hashtags, and hopefully that'll clarify your definition. Go. All right, let's see if it looks something like this. Since you already shared it with your neighbor, you wrote a numerical or variable expression raised to a power greater than 1. Hence, if you got something like that. Very good. How about examples? Who got some examples that look something like this? Good. How about non-examples? Something like that? Yes. And a couple hashtags? Yes. All right. Now, in regards to steps, you already have the steps from yesterday. We're not going to rewrite them just for the sake of time, but the steps are still the same. There's 3 steps. Identify the exponential expression is a product of powers, power of power, or power of products. Step 2, use the appropriate property to compute. And step 3, we always simplify at the end. Okay? So, quick recap from yesterday. We said that whenever you see anything that does not have an exponent, you're going to put an exponent of 1. Is that correct? We also talked about the commutative and the associative property of multiplication, and we use those to do the product of powers property. Is that correct? Yes? From there, I showed you the product of powers property. We did some examples, and then you took some home, and by the looks of it, you guys did pretty good. Appreciate it. And then from there, the only one that we didn't get to was these kind of problems, which is a word problem. And the reason I left that for today because I wanted to elaborate on scientific notation. So on the Q side of your notes, does everyone see the column right there? Yes? All right, I want you to write scientific notation. Now, this is just a general introduction. Some of you might have seen this already, but this is more in a general 8th grade standard. We're going to get to a lesson towards the end of the year because you guys are already in algebra, but I still want to make sure that we address that throughout the year. So, really quick, I want you to write this down. Let me show you what a scientific notation looks like. So, write 2.3698 times, put a big dot right here for times. Some books might show it with an X like so, so make sure you put an X like that so that you know that they might use the X or the big dot. Then it should have a 10 and an exponent. I'm just going to write, I'm going to make up an exponent. So I'm making all this up. Everybody understand? We still haven't done anything. So I'm just going to make up a number there. There it is. I'm just showing you what a scientific notation looks like. This is what we call the anatomy of a scientific notation. So what is the one thing that we notice? Underline the number 2. And we're going to write only 1 digit. Where? On the left side of the decimal. Does everybody notice that? Does it have more than 1 digit on this side? No, only 1. That means it can only have numbers 1 through 9 in this spot. Are we there so far? From there we have numbers here, it doesn't matter how many. But the next thing that the scientific notation should have is multiplication sign. The next thing it should have is a base 10. And of course, with that base 10, it should have an exponent with that base 10. Are we there so far? All right. Now that we know what it looks like, let me show you how to change a number to make it look like that. Everybody ready? All right, here we go. I'm going to write example Q, and you're still on the Q column, right? We're writing this on the Q column. Here it goes, example Q. I want you to write, give me a number. 5, 7, 1, 4, 3. So this would be 57,000, 143. So question, does this look like this? No, because it's not in scientific notation. This is scientific notation. This is what we call standard notation. So to change this, we need to find out where the decimal is at. Does everybody see the decimal? Does everybody see the invisible decimal? No, because it's invisible. So, since it doesn't have a decimal, whenever you have a number that does not have a decimal, I want you to place a decimal on the far right of that number. So let's do that right now. Place a decimal on the far right. There it is. So what is the first rule? Focus, please. What is the first rule that we find out here that a scientific notation should have? How many digits on the left side of the decimal? 1. How many does this one have? 5. 1, 2, 3, 4, 5. So what do we need to do to the decimal? Move it 1, 2, 3, 4 times. So our new number would be 5.7143. Are we there so far? What else should it have? What's the next part? Multiplication. What else is the next part? Base 10. And check this out. How do we know the exponent? Well, let's see. How many times did you move the decimal to the left? So what goes here? 4. And that's scientific notation. Boom, that just happened. Yep. Let's do another one. Example super Q. And we're still on the Q column, yes? Do this one by yourself. Let's do 958,123. Change that to scientific notation, please. Ariana, what do? Move the decimal to the end, but we don't have a decimal. So what is the first thing we do? Make it visible. So where do I place it? At the far right, okay? So then how many times do I move it? Let's move it. 1, 2, 3, 4, 5. So my new number would be what? And then? Hands if you got that. That is correct. That is scientific notation. So far so good? Let's do another one. How about if I gave you example mega Q? And let's say I gave you one that looked like this. We're still on the Q column, right? Let's say I gave you one that looked like 58.23. 58.23. And I asked you to change that to scientific notation. What would I do? Yes. Move it to the left how many times? Once. So what's my new number? 5.823. What else do I write? Multiplication sign. Base 10. And what? 1. Hands if you see that. That is correct. This will be scientific notation. Are we there? All right, so let me throw you just a quick curveball and see if you catch it. Here it goes. Example, Power Rangers Q. All right, here we go. 0.6543. All right, so Garrett says, I need to move this one to the right, okay? So my new number would be what, everyone? 6.5432, okay? Times what? 10, and the exponent would be what? Negative 1. Does everyone understand why? Yes, if we move it to the left, it's positive. If we move it to the right, it is negative. Pretty simple? Bam. So with that said, look at this next problem. It says, light from the sun travels at about 1.86 times 10 to the 5th miles per second. So in 1 second, the light travels at 1.86 times 10 to the 5th miles per second. But they want to find out how much would it be in 15,000 seconds. So for this one, I would do this. Look up. 1.86 times 10 to the 5th, but this is for 1 second. So to find out how much would it be for 15,000 seconds, I would write times 15,000. Is everybody following so far? But since these are not the same, what do I need to do to this one? Change it to scientific notation. So tell your neighbor what would be scientific notation on this one. So I heard 1.5000, but I can do without the zeros because we don't have any more numbers for right now, times 10, and how many times did I move the decimal? 4 times. Times 1.86 times 10 to the 5th. Now, this is looking more like yesterday's home plate. Are these the same base? So I end up with 10 to the what? 9. Are these the same kind of numbers, and are we multiplying? Yes. 1.86 times 1.5, so what? 5 times 6, that's 30. I have 3. 5 times 8 is 40, plus 3, that's 43. I got 4. 5 times 1 is 5, plus 4, that's 9. Then it's 6, 8, 1, 0, 9, 7. Bringing up the 1, it's 2. How many decimal places? 3. So this is 2.790. Is this scientific notation? Yes, and this is in miles. Okay. Does everybody see what to do when we encounter something like that? Fairly simple? Yeah? So therefore, that's what I wanted to touch up on before we got to today's property. Today's property in the back, before I give you the property, let's just recap what we saw yesterday. Look up, please. Did we cover product of powers property? Bless you. Yes. What did it say? If the bases are the same, what happens to the exponents? If the bases are the same, what happens to the exponents? You add them, right? Is this what this is showing? Yes. Let me show you with numbers. 3 to the second times 3 to the 0 is the same as 3 to the second plus 0, yes? Which is still 3 to the second. What is 3 to the second? 9. So this is 9, this is 9, this is 9. But we're missing this one. Well, let's find out what that is. 3 to the 0. 9 times what equals to 9? 1. So what can we conclude? That 3 to the 0 is 1. You're like, what? That's kind of weird. Well, let's see if it works with another number. 5 to the second times 5 to the 0, is that the same as 5 to the second plus 0? Which is still 5 to the second. Is that correct? What is 5 to the second? 5 times 5 is 25. This is still 25. This is still 25 times, but we're still missing a number there. 25 times what gives me 25? 1. Therefore, tell your neighbor, what can we conclude with numbers that look like this to get that? What can we conclude? Heaven, what can we conclude? Bam! Did everybody hear that one? Anything to the 0 power is 1. So what if I said Andrew to the 0 power? What would you say? 1. Is that correct? Does that make sense? All right. So now that we covered that, look at this one. What if I just wrote 3 to the second times 3 to the first? Isn't that the same as 3 to the second plus 1, which is 3 to the third, right? 3 to the third is 3 times 3 times 3. What is 3 times 3? 9 times 3, that's 27. This is 27. What is 3 squared? 9. Therefore, we're still missing a number here. 9 times what gives me 27? So we can conclude that 3 to the first is 3. So let's see if that works with other numbers. Let's see. 4 to the second times 4 to the first is the same as 4 to the second plus 1, which is 4 to the third, yes? So 4 to the third is 4 times 4 times 4, which is 64. This is 64. This is 16. Therefore, 16 times what gives me 64? 4. So look at this and look at this. Tell your neighbor what we can conclude from that one. Jason, what can we conclude from that? Any number to the exponent of 1 is the same number. Does that make sense? So what are the two things that we learned right now? That any number to the 0 exponent is 1, and any number to the 1 exponent is the number itself. We got it? All right, so with that said, turn your paper over. In the back, I want you to write power of powers property. Power of powers property. Power of powers property. Power of powers property. And write example Q. All right? Power of powers property. Write this down, parenthesis, 2 to the third power, close parentheses, to the fourth power outside. Bam. Underneath that, I want you to write parentheses, x to the second power, close parentheses, and outside to the fifth power. I know, right? Underneath that, I want you to write parentheses, 3 to the fourth power, close parentheses, and outside of that to the fifth power. What's that? Oh, yes. Yeah, but we're not going to do that right now. Let's just focus on the property. Okay, writing utensils down, look up here. So once again, I'm going to stay quiet, let your noodle do all the work, and then I'll have you guys share with each other, and then from there we're going to come up with a definition. Look up, please. Tell your neighbor the rule for the property, powers of powers property. All right, copy that, and then we'll go over the definition. You guys will help me with that. Copy that, please. So, you shared with your neighbor, and underneath, I want you to write asterisk and a heart. Oh, so we can write our definition. So let's see. And I'm going to get us started. When, what? What's happening in each of these? Let's see. Andrew, when what? Okay, so what is this called? What you just said? When a base and an exponent. What is that called? When a base and an exponent. What is this called? When an exponential expression is what? Parenthesized, okay. In parentheses, I'll take that, is in parentheses. And what? Has an exponent on the outside, comma, yes? You multiply what? The exponents. The exponents. Period, and then 10Q. Now, check this out. Andrew said when an exponential expression is in parentheses and has an exponent outside. All that, what he just said before the comma and after the is, from here to here, this is what we call this term. Write it above that, raised. Raised. What he just said in regards to in parentheses and has an exponent outside. So that's what we call when an exponential expression is raised. Okay? And you multiply the exponents. Okay, we got it? Fairly simple? Okay, let's try it out. Example, now, how about Michael Jordan Q? Bam! Ha 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 ha. All right, here we go. Parentheses, a to the 50th power, close parentheses, to the 4th power. Don't say it out loud. Don't say it out loud. Write it down, and then we'll share it. All right. Leah, what'd you get? A to the 200th power. Hands if you got that. Okay, we get the rule now, right? Yes. All right, so now let me go back really quick so you can see why this works. Look up, please. Write your utensils down. Now, before I show you the example, let me show you this. 2 to the 3rd power is the same as 2 times 2 times 2. Is that correct? Okay, now that we got that in our noodle, check this out. 2 to the 3rd power to the 4th power. What does this mean? That 2 to the 3rd power, how many times? 4. 2 to the 3rd, 2 to the 3rd, 2 to the 3rd. This is this, yes? Now, what does this look like? Product of powers property, doesn't it? Are these the same base? What happens to the exponents? Add 3 plus 3 plus 3 plus 3. Bam. Everybody see that? So now, in case you guys have, you might think you made a mistake going from here to here. I tell my kids every year, I tell you guys, when in doubt, factor out. This is what we call factoring. When in doubt, factor out. Copy that, please, so at least you have that as an example, please. When in doubt, factor out. How we doing? Yes? So yesterday we covered product of powers. This one is power of powers. And the last one that we need to write is power of products. So write that underneath that, power of products. Example, super mega Q. How about that? There it is. Write this down. Parenthesis, 2 to the 5th, x to the 7th, y to the 8th, close parenthesis, to the 3rd power. So now before we use the rule for this one, what do you notice the difference is from power of products than power of powers? Tell your neighbor. What do you notice is different? Sergio, what do you notice? There's more exponential expressions. It has more products, right? So but however, the rule remains the same. Look up. Look what I'm going to do. So, with that said, who can give me the simplification of this? Who has it? Ian.
Other than the 2 to the 15th.
So it's 2 to the 15th.
Times x to the 21st.
X to the 21st.
Times
Y to the 24th. Hands if you see it. Okay. So now we covered already multiplication properties. Show me with your fingers how comfortable you feel with these. 1 being the lowest, 5 being the highest. Where are you at so far? We got some 4s, 4 to 3s, 3.5. Some of you have weird fingers. 5s, 4s. Okay, so we're getting there. We need some practice tonight, yes? So for tonight, your home play for tonight is play sheet 7.1. And on one side, you're going to do numbers 1 through 15. And on the other side, do numbers 1 through 18 only. Okay? And once again, I'm going to upload the video at the end of the day, so in case you need to revisit, just go to this. Yes? All right? As soon as you're done, come pick up a home play sheet from up here, and then wait for the bell, and see you guys tomorrow. Enjoy your home play. Bye.